Hey, welcome to the second part of section 1.5. We were talking about radical equations and then equations that can be written in quadratic form, and we're going to do absolute values. So I thought I'd do one more in quadratic form. There's an interesting looking problem, number 61, that I'll do. 61 is 1 over x plus 1 squared equals 1 over x plus 1 plus 2. Alright, so since these are the same but 1 squared, this can be written in radical form, I think, right? So let me get everything over here first, and so that actually I'm going to do the substitution first. So I'm going to let w, and you can use whatever letter you like, equal 1 over x plus 1. So if w equals 1 over x plus 1, then w squared is going to be, well, you square that and you get 1, and you square that and you get x plus 1 squared, right? So now I can replace this whole thing with w squared equals, that's w, and that's 2. Alright, so now if I bring it over, I get w squared minus w minus 2 is 0. And that will factor to what? W minus 2 and w plus 1. So w equals 2 and w equals negative 1. However, negative 1 can't work. As you can see right here, you're going to have a problem. If you put a negative 1 into the original, you're going to get 0 on the bottom, and that's a no-no. So that's obviously an extraneous solution. However, 2 probably works. So if I put 2 in there, let's see, this is going to be 2 plus 1 is 3. 3 squared is 9, so that's 1/9, right? So it would read 1/9 equals, if I put a 2 in there, I get what? Oh wait, I'm not done. I just realized it's not working out. It's because I'm not finished. I gotta solve for x, so let me go back. Okay. So I have to resubstitute, right? Remember, w equaled x 1 over x plus 1, so I need to replace w with 1 over x plus 1 is 2. Alright, now I have to solve for this, so I'm going to solve this by multiplying both sides by x plus 1. If I multiply this side by x plus 1, I get 1, and this will be 2 times x plus 1. And then I'll distribute that, so 1 equals 2x plus 2. Subtract the 2, I get negative 1 equals 2x, and then I get negative 1/2 is x. Alright. There doesn't seem to be a problem with the negative 1/2. Alright, this one, w equals negative 1. So remember, w is that. So that would be 1 over x plus 1 is negative 1. Then I multiply both sides by x plus 1. That gives me 1 equals negative 1 times x plus 1. So 1 equals negative x minus 1. So add 1, and I get 2 equals negative x. Therefore, negative 2 equals positive x. And that doesn't appear to be a problem either. Are they both solutions? As long as they don't give you a 0 on the bottom and you don't have any radicals here, I think that's going to work. So let's graph it and see what we get. So the first equation is 1 over parentheses x plus 1 squared. And the second equation is 1 over parenthesis x plus 1 close parenthesis plus 2. I'm looking for the intersection of these two graphs. I'll make the second one bold just because I think it's going to be a lot going on with these two graphs, so we can distinguish them, and I'll hit zoom 6 to give me a standard window. Alright. So I think I can shrink in a little bit. I don't need all this area over here if I want to, so I can get rid of a lot of this and a lot of this, right? So I will go in my window, and my x minimum, I'll make it -3, and I'll make my x maximum +3 and see what that does for me. Alright, and you can see that there's two places here it crosses. I'm just going to do one more thing. I'm going to make my x max 0. There's 1. There's 2. So there's one solution. There's another solution, right? So that solution is -2, and that solution is -1/2. Do an intersect and make sure I'm thinking of this right. So there's -2. Do another intersection. There it is. And -0.5. So that works out. So that's number 61. The next section we're going to talk about is absolute value equations. So number 67 is the absolute value of 2x plus 3 is 5. Now keep in mind, an absolute value turns everything positive, right? So what's inside of here could equal 5, because the absolute value of +5 is 5, but it could also equal -5, because the absolute value of -5 will also give you 5. So you have to set up two equations. So what's inside the parentheses, which is 2x plus 3, could equal 5, or the 2x plus 3 could equal -5. Right? So 2x is equal to 2, so x could equal 1, or 2x could equal -8, so x could equal -4. So the two solutions are 1 and -4. Let's graph that. So absolute value is found by going, you can go to math, one place to find it anyway, is to go to math over the number, and it's the very first one, ABS, and it's 2x plus 3, and then the second equation we'll just graph 5, which will be a horizontal line. I'll hit zoom 6. So it always has that V shape, and as you can see, there's the -4 solution, and there's the solution that is 1. Okay. So that's an example of an absolute value. You definitely want to isolate the absolute value when you do them. So let's look at another one. I'll do 70, I guess. Be good. The absolute value of 1 minus 2z plus 6 equals 9. So what I want to do is subtract that 6 over first to isolate the absolute value. And then set up my two equations. So 1 minus 2z could equal 3, or 1 minus 2z could equal -3, right? So if I subtract 1, -2z would be 2, so z is going to be -1, and over here subtract 1, -2z could be -4, so z could be +2. So those are my two solutions, and they should both work. Alright. One more of these. 83 is the absolute value of x squared minus 2x equals 3. So x squared minus 2x could be 3, or x squared minus 2x could be negative 3. So we bring that over to set it equal to 0 because it's quadratic, and we want to either factor it or use a quadratic formula or whatever we have to do. So this will be x squared minus 2x minus 3 equals 0. And I think we can factor that to what? X minus 3, x plus 1. So x could be 3, or x could be negative 1 from that side. If I bring the 3 over here, I get x squared minus 2x plus 3 equals 0. Will that factor? I don't think it will. Right? Can you think of two numbers that multiply to 3? The only two numbers I know of that multiply to 3 are 1 and 3. Right? And at least whole numbers. Or negative 1 and negative 3. But negative 1 and negative 3 add up to negative 4, not 2. So we're going to use the quadratic formula on this one. Alright, so let's do that. It'll be x equals negative b, which will be 2, plus or minus the square root of b squared. When you square that, negative 2, you get 4, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 2 times 1, which is 2. Alright, so what do we have? X equals 2 plus or minus the square root of 4 minus 12 over 2. So 2 plus or minus the square root of negative 8 over 2. So x equals, I can break negative 8 up into negative 4 and 2, right? And the square root of negative 4 will be 2i. And then the 2 will just stay underneath the radical. Right, so that's what I'm going to do. So 2 plus or minus 2i on the square root of 2 over 2. A lot of 2's. So these 2's right here, they cancel out, become 1's. So this becomes 1 plus or minus I on the square root of 2. Alright, so we have 4 solutions, right? 4 solutions. We have 3, negative 1, 1 plus I squared root of 2, and 1 minus I squared root of 2. Notice that, I don't know if I said this in the video on quadratics or the complex, I should have, that if there's a complex solution, then its conjugate is also a complex solution. That's always the case, right? So if 1 plus I squared root of 2 is a solution, if I told you it was, then you automatically know that 1 minus I squared root of 2 is going to be a solution as well. Right? They always occur in conjugate pairs like that. Alright, what else do we have? Problem set from 85 to 94. I'll do 1 or 2 of those. So let's look at 85. X cubed minus 9x equals 0. Take out the x, so that's x, because they both have an x, so factor it out. X squared minus 9 equals 0. Alright, so now you can either factor that or just solve it directly, right? If I want to factor it again, it'd be x plus 3, x minus 3. So the 3 solutions are 0, because that's a factor, so if x equals 0, then 0 times whatever is going to give you 0. What will make this one 0? Negative 3, right? So x equals negative 3 is a solution, and this one would be positive 3. X equals positive 3. So these are all solutions for problem 85. Let's see what that graph looks like. So x raised to the third minus 9x. 1, 2, 3 solutions. All right. 89. X cubed plus x squared minus x minus 1 equals 0. All right. I think if I rearrange them, put these two together. So if I do x cubed minus x and group them, plus x squared minus 1. The reason I'm going to do that is because when I pull out an x right here, it's going to look just like that, right? So when I factor out an x, now I have x squared minus 1 plus, there's nothing to factor out here, but you can always pull out a 1 if you like. It kind of shows what's going to be left over. So x squared minus 1 equals 0. Now if you notice, these two terms have x squared minus 1 in common. So I can factor out x squared minus 1, leaving behind x plus 1. Right. So I factor out x squared minus 1, and that leaves me with x plus 1. Pretty clever, huh? And then this can be just set equal, you can factor it, so why don't we just factor it? So it'll be x plus 1, x minus 1, x plus 1. So we see the solutions are 1 and negative 1, but negative 1 is a double solution, right? It's a double root. So the solution set would technically be negative 1, negative 1, 1. So what does that graph look like? So x cubed minus or plus x squared minus x minus 1. Alright, so right here you see how it just touches at negative 1? That's why it's a double root, right? It bounces off, it does not pass through, so we call that a double root. Let me zoom in on it a little bit. Bounces off it there. So you have 1 and then negative 1 twice. Alright, what else do we have? That's really about it. Try one more. 94. Something I might struggle with here. I haven't looked at it. Let's see. What could we do? I wonder if we can do something like we did with the last one. So if I put those two together, they have 3 in common, right? So if I factor out a 3, I think that'll be a 9. If I put those two together, factor out a 4, and you'd have a 9. So that's what I'm going to do. I'm going to bring over the 27 with the 3x cubed. So 3x cubed minus 27x. So those go together. Plus the 4x squared. Bring over the 36, so it'll be minus 36. Those two guys are together, equals 0. Alright, so what do they have in common? 3x, right? So I can factor out 3x, and that will leave me with x squared minus 9. Plus, these have 4 in common, so I'll factor out a 4, leaving me with x squared minus 9. Alright, so now I can factor out x squared minus 9. So x squared minus 9, and then 3x plus 4. and x squared minus 9 factors to x minus 3, x plus 3, and 3x plus 4. Alright, so what does the solution say? Well, 3, because that 3 will make that 0. Negative 3. And negative 4/3. If you're not sure how I did that, just set it equal to 0 and 3x plus 4 equals 0 and solve it, right? And you should get negative 4/3. And that is the end of the chapter. There are a few applications, but I'll save that for later. Thank you so much for watching, hanging in there. Good job.